All right, take it away.
Everyone is excited. This is the last one.
Yes. Oh, yeah. Audio.
Sure.
Mic check. Yes, turn on the.
Oh, better? Okay, cool. So I'm Ihar. I work for OpenStack networking team, so not really core OVN, but still since it's the new default networking solution for us, I tend to work with it. So today I'm going to talk about live migration, problems with the network disruptions that we have in OpenStack during this procedure, and how OVN may help us. So first of all, what is live migration? Well, first of all, what is migration for a VM? You have a workload, you have a VM running, you want this workload somewhere else on some other node. Well, the easiest thing you can do, you can stop the VM, you can start it in a different place. The problem, you run software inside the VM. Ideally, you don't want to disrupt it. So that's where live migration comes in. Live migration, at least in theory, should allow you to migrate a running virtual machine to a different host in such a way that there is no visible disruption to any software running in it. And that means also no network connectivity disruptions. So any software that relies on that external network connectivity that is running inside the VM is supposed to not see this process happening under the hood. Why would you do that? Well, plenty of reasons, but usually you just need to do some maintenance steps on one of the hosts that is running VMs. You don't want to disrupt them, so you drain the node, and then you do whatever you need to do. Update firmware, kernel, any other packages, whatever you need. So how is a VM migrated, live migrated? Well, it's a complex story, but we can try to describe it in simple terms. So there are a bunch of things you should do. So first of all, the VM is running, so there is plenty of state that is attached to this VM. So all this state should be copied to a different machine where you want it to eventually land. This is happening while the VM is running, so the VM continues to change this state, so you're trying to keep it up. So this process can take a while. Anyway, assuming you kept up and you have a complete copy of your state of the VM in a different place, you're ready to move to the next step, which is pausing the VM on the original destination. Since you have the full state in the new destination, you should be able to unpause it there. At this point, any software that was running in the VM resumes, which is fine, except there's one thing missing. There's still no network connectivity. So you also need to configure your network solution to serve the ports that belong to the VM in the new place. So first I will go through how OpenStack live migration generally looks like. And then I can show you why there may be some place for improvement. So on the picture, you see two chassis. One of them is running a VM inside the libvirt hypervisor. Both of them are running an OVN controller. The VM is plugged to an OVN port. In OVN we bind VMs to particular hosts using this requested chassis option on the port. So we make sure that the port lands where we want it to land. So in this case, it is set to source. And now we want to move the VM to the other chassis. So first of all, we create a VM template that describes the VM in the new place, and then starts to dump the state while the VM is still running, which is fine. Everything works. Now the state is copied, and we are ready to proceed. So we pause this VM on the source chassis. It is down. At this point, no software is running. But we immediately move to the destination. We unpause it. The VM is up. Oh, nice. All the processes are back. We can see them doing some work, but the problem is that they still don't have network connectivity. So at this point, we request moving the port to this destination. It takes a while. There are a bunch of components involved, but eventually the port lands to the destination. We plug the port, and the VM can send packets and can receive them. It kind of works. Now we can just delete the old VM from the old place, and this is it. We're done. The problem with that is that while this works, there's still some network disruption that we experience. Yeah, for some people, one may say it's not that big of a deal, but if all goes well, it takes 2 to 3 seconds of the network downtime for a port to move to a new place. That's if all goes well. There are multiple components involved. Since my port move is triggered by compute service of OpenStack that talks to Neutron to do the job, that talks to OVN North D, that then translates to southbound, and OVN controller is supposed to take it over and finally configures the port. It may take a while. Any component that is slow or failing in the middle, it leaves the VM with no network connectivity for a long time. And the very simple task how we can show it is just run a ping. Here I pass -i 0.01 parameters, which mean that the interval between the requests is 1 millisecond, and then we can just check how many packets we haven't received a reply from the VM that is being live migrated. In this example, we see just a bit more than 200 packets, which comes down to 2+ seconds. We want to be better. So there are two sources of potential network disruption here. First of all, there's this very short phase when the VM is not running anywhere. While this is a theoretical problem, it's not a real problem because we experience like downtime of the machine of less than 1 millisecond. Another part of it is the time when the port is actually being moved from one place to another one, and that takes, as I said, 2+ seconds in the best scenario. That's what I was saying, that lots of components are involved, and in the meantime, the apps are running inside the VM. They don't have connectivity. They are getting timeouts or whatever. So what's the solution that we came up with? First of all, we realized that maybe we don't need to wait for the VM to be completely moved to the destination chassis to actually start configuring the port there. So maybe we can start configuring the port at the same time when we started dumping the VM state to the destination. And another problem is related to the components, that we don't really want to get into the situation where VM is already running on another host, but something fails somewhere or just being slow that doesn't get us network connectivity quickly there. So we came up with something called multi-chassis port bindings, which is nothing more than just an ability to configure not a single to bind port binding not to a single chassis but multiple. So we expanded the syntax of this request a chassis option to allow passing a list of chassis names. In this way, we can keep the port binding active, actively serving packets coming to the VM while it's running on source, while already doing the configuration of the port on the destination. And the second step is, while this will make destination chassis configure its flows, all the other nodes in the cluster should also be aware of that the port binding is now located in multiple places, and should make sure that any packets that are directed towards this port binding are delivered in multiple places. Now, in live migration scenario, since we don't actually have a case where the VM is running in parallel at the same time in multiple places, in reality, like half of the packets are just dropped, half of the because they are not needed, but half of them are delivered to the VM, but that's fine. So now let's check how it looks like with this. So again, we start with the same. There's a VM. We request live migration. Everything is the same. We started copying the state. But now we're not waiting for the live migration to complete before we move the network, the network port. So we request from the OVN to deliver this port binding to the destination chassis too, in addition to source. In this way, source can still be connected. OVN does its thing. It brings up the port, and we start mirroring all the packets that go to the original to the main port binding location to any other locations, in this case to the destination. Now again, VM is not running there, so it's not doing anything with these packets. But this will be needed when it actually is brought up. So again, we continue copying the state. Finally, the VM is ready for the switch. So we pause it, the original VM, and we unpause it there. And right at this moment, all the software that relies on network connectivity is ready, because the port is ready, all the flows are configured. That's nice. We still need to clean up the old location of the port binding, since we just don't need it. But it doesn't. This procedure can be done asynchronously. It doesn't affect our actual traffic flowing. So at this point, yeah, we can delete the VM, the old port binding location, and we're done. So we just eliminated the second source of the disruption, and we're left with something that we consider negligible. So let's see whether it works. So yeah, it is. It does. Actually, this was something unexpected to me. Like I expected some losses, right? There should still be some, but no, not really. You can see in this output you have exactly the same number of packets that were sent as received. There is only one caveat. There are some duplicates there. So where did they come from? Actually, I'm not exactly sure, but I suspect that this is because while the live migration is supposed to guarantee you like exact atomic switch of the state, but I suspect it's not really the case. Maybe some packets were cached somewhere. Maybe I don't know. So clearly, we brought up the port. Brought up the ports to early, I guess. If that's the problem, maybe it's not the problem, actual problem, but maybe we want to solve that. So one thing that may help us is that libvirt, which is the hypervisor used by OpenStack, it always once live migration is done, once VM is brought up in some new place, it issues itself, not the VM, but libvirt itself will issue a bunch of reverse ARP packets just to tell the network that this MAC address is located in a new place, and we can use that as an indication that libvirt actually believes that this VM is ready. So what we did is we introduced another option for the port that you can set, which is called activation strategy, even though in theory it allows other strategies. We just implemented the one that we're interested in. And what it basically does, if it's set, then all additional chassis, while they get to the port binding pre-configured, this port binding is blocked from all ingress and egress traffic that belong to the port. So we make sure that nothing flows from the VM until we believe we're ready. So, and that's why there's this exception. There's a special rule where we capture just reverse arcs that come from the VM, not from the VM, from the port of the VM. When we see this packet, we immediately know that Livert just told us that we're ready, so we pass this. We capture this packet with a controller action, and this controller action will remove the flows that were dropping all the traffic that belongs to the port. So once route is received, almost immediately we unblock the port for further processing. And this works. So with this, we get to this point. Now we're losing some packets. We just lost 4 packets since we're running with 1 millisecond interval. It comes to 4 milliseconds, which I guess is more than 0, but we don't have double hits anymore. And in the end, 4 milliseconds is slightly better than what we had before. And perhaps, while this is impressive, perhaps what we were more concerned, since we had some actual customer issues related to that, that during this activation of the port, no components that are external to OVN, no databases are involved. It's just localized with OVN controller. So even if neutron is down at this point, or OVN, the North-D, we don't care because the flows are removed locally by the controller. I guess that's all I have.
Thank you very much. I guess we're gonna go one round. Does anybody in the room? We have one question in the back.
Thanks, great presentation. My question is like when OVN, what happens if OVN controller is down when RARP is sent? You know, it's fine if it binded the port, but then it's down, or maybe the pin controller thread way too much time.
For some time, and then it's up, back up.
Yeah, what happens if it restarts during that time, basically?
We should think about it.
Because
unless Libvirt will continue doing it, and I don't think it does.
Okay.
Yeah, we may be.
Are we in dangling state during that time? I mean, will the VM be in the dangling state during that time until, on the other side, Libvirt deletes that VM and the strategy is changed?
Well, one thing that may be of relevance, yes. If this happens, you won't get your traffic unblocked immediately. But the way live migration actually works is once this is done, you immediately start cleaning up all the old resources, including the port, which will, among other things, will remove the activation strategy. It's no longer needed, so you will get all these blocks removed anyway, but through the DB. Again, if everything is broken there too, then you're still at the problem. But then
it's the same question.
All right, thank you very much. Do we have any more questions in the room? No questions on virtual. We have one question. Do we have anyone else? Okay, Flavio wants to go. We love you, Flavio.
You guys getting sick of me. I'm definitely over my quota of questions for the day, probably for the event. Ihar, can you talk a little bit about the mirroring? I'm very curious how that's set up. Is that at the OBS level, or do you do it through OVN, the mirroring piece?
Yeah, that's something that I removed from the presentation. So in theory, like now we have this mechanism where you can get traffic mirrored to a different place, right? You could in theory use it for something else. And the way we actually designed it, it's not really tied to live migration. You can have more than two stress locations. It may be not transient, though then this then you probably won't need won't use this activation strategy. So in theory, first of all, this may be useful beyond live migration. It already gives you a mirroring capability. The way it's implemented is just an extension of existing flows in, I think, table 37 or 38, the one that handles both the like one table handling the local processing of traffic and another one sending to the remotes. So both of them, I think, are updated so that if needed, if the port is multi-shafted, then it is also sent to additional tunnels. And then the other side will handle it itself.
So it's basically an action where you have multiple outputs.
Yeah, just an additional output before like after tunnel.
All right. Do we have any last questions? All right. If not, just one quick announcement. There was a talk by Mahmoud. He could not present that talk. We'll figure out the details for that later. In the meantime, I think we're all set for day 2. Big round of big. How do you say those words? I forgot. Big applause, everyone. Thank you.